Hi everyone. In this very brief video, I just want to look at some generalized projections and aggregate functions. My green screen has been acting up, so I won't have video, but later on we'll have that back. And then for the SQL intermediate, you'll see some of the REPLs we could use as well. In general, a projection is where we push arithmetic functions onto a list of items inside of our attributes or any type of expression that we have here. For instance, in our example here, if we have a relation instructor with these attributes where salary is the annual salary, we can get the same information but with a monthly salary. So this is a generalized projection where we say, go ahead and get the ID, name, and department, and then have the salary divided by 12 to get that monthly one. So this helps with expression power and ensuring that we can get more complex relations from there as well. However, the issue here is that we usually don't have a way to change these attribute values in depth with standard relational algebra. What we could do then to help account for this is this aggregate function and these operations that help with it. These are probably things that you've seen before, but again, there's going to be applied in a relational algebra term. So again, basic aggregate functions could be average, minimum, max, count. And then essentially, if we have a list of attributes on which to group from G up to G of M, we could apply these types of functions to them there. So for my group of F, I'm going to apply my function 1 to my attribute 1, function 2 to attribute 2, and just kind of apply them across the word using relational algebra. Cool. So one relational algebra here is if we have a relation R, sorry for the beep. If we have relation R, I can go ahead and say, get a generalized function, sum, that takes in my attribute C here and apply it to my function R. And what this will do here for me is essentially apply this function sum that's either built in or something that we can code ourselves, and then provide me with an output of the relation R with the sum of C there, okay? So again, this is stuff you might have seen in lists before, but this is the same idea for our functions inside of relational algebra. We could do this again. So we could say inside of our relation instructor, go ahead and grab the department name of each department and average the salary. So apply this generalized function to each department there. Kind of split this into something along the lines of here, and then we'll get an output of their average salaries. So one more thing here is that we can allow renaming in these aggregate functions and these results because we can sometimes have averages too often applied to the same ones. We might have different types of average salaries where maybe we want to average but also make some tax. So what we could say here is we can use these two terms of as or the arrow over to rename what we're actually applying to our function here. So again, this isn't SQL code just yet, but this is just this type of idea of relational algebra where we say grab the department name, and for my general function, apply the average to each of the salaries from whatever's found in the relation to department name, and use this aggregate function as average salary. So this is a new name we used, or you could say arrow over to average salary as well. Cool. So again, what we could say here, if we get the average salary of each department, what we could say here is go ahead and create this function that we saw earlier. And now select where any salary is greater than the average salary, and then do a Cartesian product of that one there. And this is what we'll get out from here too. Okay. So again, this isn't SQL code just yet. This is still relational algebra, but this is a general idea of what we could do with aggregate functions.